Welcome, curious minds, to another journey into the profound mysteries of our world. Tonight, we plunge into the vast, shimmering depths of our planet's oceans, a realm still largely unknown, yet teeming with life beyond our wildest imagination. We'll explore an audacious endeavor, a colossal undertaking that sought to peel back the watery veil and count the beating hearts of the deep. Prepare to be swept away by the scale of discovery, the power of collaboration, and the sheer wonder of marine life. Settle in, find your calm, and let the currents of knowledge carry you. And as always, if this exploration resonates with you, consider liking, commenting, and sharing this journey with others. Narrator. Beneath the shimmering surface, beyond the reach of sunlight and human sight, lies an expanse so vast, so profound, it beggars the imagination. Our planet, blue and vibrant, is truly the world of water, and within its depths, life thrives in forms both familiar and utterly alien. For centuries, our understanding of this colossal aquatic realm was akin to gazing at the stars through a keyhole, tantalizing glimpses, but never the full, breathtaking panorama. Yet there was a time, not so long ago, when a bold, audacious idea took root. An idea to count the uncountable, to chart the uncharted, to paint a living portrait of the ocean's boundless biodiversity. This monumental undertaking, born from a spirit of scientific curiosity and a profound appreciation for the unknown, would come to be known as the Census of Marine Life. Imagine, for a moment, the sheer scale of such an endeavor. A global network of researchers spanning over 80 nations, uniting under a single, ambitious banner. Their mission: to meticulously assess, to beautifully explain the sheer diversity, the intricate distribution, and the staggering abundance of life teeming within our planet's liquid heart. It was a project that would demand dedication, ingenuity, and a collaborative spirit unlike almost anything seen before in the annals of science. The genesis of this global odyssey can be traced back to a series of conversations in 1996. Jesse Ozabel, a senior research associate at Rockefeller University, and Dr. J. Frederick Grassel, a distinguished oceanographer and benthic ecology professor at Rutgers, found themselves discussing a grand vision. Grassel, a man deeply immersed in the mysteries of the deep sea, had been encouraged to connect with Ozabel, though he was initially unaware that Ozabel also managed programs for the Alfred P. Sloan Foundation, a philanthropic giant known for funding large-scale, public good scientific projects. Think of it similar to the Sloan Digital Sky Survey, which sought to map the cosmos. Ozabel, with his unique ability to identify and champion groundbreaking initiatives, recognized the immense potential in Grassel's vision. He played a pivotal role in persuading the Sloan Foundation to allocate resources for a series of feasibility workshops between 1997 and 1998. These crucial gatherings were not merely brainstorming sessions. They were intense, collaborative explorations into how such an unprecedented project might actually be conducted. What began as a nascent idea, perhaps a census of the fishes, quickly expanded, growing in scope and ambition to embrace the entirety of marine life. The outcomes of these workshops, coupled with a wealth of invited contributions, formed the bedrock of a special issue of Oceanography magazine in 1999, a testament to the burgeoning excitement and intellectual rigor surrounding the proposed census. Later that year, another pivotal workshop in Washington, D.C., addressed a critical need: the establishment of the Ocean Biogeographic Information System, or OBIS. This would become the central nervous system of the census, designed to collate existing knowledge about the distribution of marine organisms and to serve as the project's indispensable information management component. The Census of Marine Life officially commenced in May 2000, marked by the announcement of 8 initial grants totaling approximately $4 million, all dedicated to bringing OBIS to life. This significant milestone was reported with deserved fanfare in Science magazine. Concurrently, an international scientific steering committee, formed in 1999, began to shape the operational framework. By 2001, they had envisioned a series of pilot field programs for the period of 2002 to 2004. These initial explorations, alongside OBIS and another groundbreaking initiative known as the History of Marine Animal Populations, or HMAP, would lay the groundwork for the census's core activities. This initial phase was designed to be followed by an additional series of field programs between 2005 and 2007, culminating in a comprehensive analysis and integration phase from 2008 to 2010. During its operation, another vital non-field project emerged, the Future of Marine Animal Populations, or FMAP. This focused on the challenging yet essential task of forecasting the future of life in the oceans, utilizing sophisticated modeling and simulation tools to peer into the potential destinies of marine ecosystems. The operational methodology of the census was a marvel of collaborative funding and scientific oversight. Project proposals were rigorously debated within the Scientific Steering Committee. If recommended for funding, a formal submission would then be made to the Sloan Foundation. This funding supported the principal investigators, a project coordinator, crucial meetings for participants, and essential synthesis, education, and outreach activities. A key element of the Sloan Foundation's approval process was the promise of contributions from additional sources, and projects were actively encouraged to secure further resources during their implementation. This strategic leveraging of initial funds allowed the census to grow far beyond its initial financial commitment, blossoming into a much more substantial and impactful program. Beyond the direct research, the Sloan Foundation also provided critical support for the census's core infrastructure, the International Scientific Steering Committee and its Secretariat, the U.S. National Committee, and an education and outreach network. These components were vital for elevating the project's global visibility and engaging a wider array of nations and organizations. Ultimately, the Census of Marine Life was estimated to have cost an astonishing $650 million. Of this formidable sum, the Sloan Foundation contributed $75 million, with the remainder generously supplied by a vast consortium of participating institutions, countries, and national and international organizations, both through direct financial contributions and invaluable in-kind support. In a reflective review published in 2011, David Penman and his co-authors eloquently summarized the profound origins of the census. The census had its inception in a visionary leader, Grassel, who was able to convince a small group of colleagues of a need for such a project and find a like-minded individual, Ozabel, who saw the opportunity for the Sloan Foundation to take a key role in bringing the census to fruition. This was not leadership that sought out problems to solve. It identified an issue that could not be addressed through conventional national funding mechanisms and could only be approached through a large-scale collaborative endeavor. The Sloan Foundation saw the opportunity to facilitate new science that would also contribute knowledge for wide societal benefit. This assessment perfectly encapsulates the pioneering spirit that breathed life into the census, recognizing a monumental challenge that demanded an equally monumental collaborative response. The census program was structured around three overarching themes, each framed by a fundamental question. What has lived in the oceans? What does live in the oceans? What will live in the oceans? These questions guided an intricate web of research, with the largest component dedicated to investigating the present state of marine life. This involved 14 distinct field projects, each meticulously designed to sample the biota within one of 6 distinct realms of the global oceans, employing a diverse array of cutting-edge technologies. Let us explore some of these remarkable field projects, each a testament to human ingenuity and a thirst for discovery. In the frigid, majestic expanse of the Arctic Ocean, the ARC-OD, or Arctic Ocean Diversity Project, meticulously documented the life thriving beneath the ice. Conversely, at the Earth's opposite pole, the CML, or Census of Antarctic Marine Life, braved the icy waters of the Antarctic, revealing a surprisingly vibrant ecosystem. Journeying to the colossal underwater mountain ranges that crisscross our planet, the MERECO, or Mid-Atlantic Ridge Ecosystem Project, explored the biodiversity around these immense geological features. And where the Earth's crust cracks open, releasing superheated, mineral-rich fluids, the CHESS Project, the biogeography of deep-water chemosynthetic ecosystems, investigated the unique life forms that flourish in these extreme, lightless environments, creatures that draw energy not from the sun, but from chemical reactions. Descending further into the crushing pressures of the abyssal plains, the vast flat expanses of the deep ocean floor, the Pseudomar, or Census of Diversity of Abyssal Marine Life, sought out the resilient organisms adapted to these remote depths. Towering underwater mountains, known as seamounts, with a focus of Censim, the global census of marine life on seamounts, uncovering pockets of unique biodiversity on these isolated peaks. The dynamic boundaries between continents and the deep sea were explored by COMARCH, the Continental Margin Ecosystems Project, examining the rich tapestry of life where land meets the abyss. Closer to shore, on the continental shelves, the Post, or Pacific Ocean Shelf Tracking Project, utilized sophisticated tagging technologies to track the movements and migrations of marine animals. The delicate ecosystems of the nearshore regions were the subject of NAGISA, Natural Geography in Shore Areas, documenting the intricate life found along coastlines. And in the vibrant kaleidoscopic gardens of the sea, CREEFs, the Census of Coral Reefs, undertook a comprehensive inventory of these critically important, yet vulnerable marine habitats. Beyond these geographically defined projects, others focused on specific types of organisms or ecosystems. GOMA, the Gulf of Maine program, honed in on a regionally significant ecosystem. The microscopic world, the unseen architects of marine life, was explored by ICOMM, the International Census of Marine Microbes. The swirling, drifting clouds of zooplankton, the essential base of many marine food webs, were counted and categorized by CMARZ, the Census of Marine Zooplankton. And finally, the apex predators of the ocean, the majestic giants that roam the seas, were tracked and studied by TOPP, the tagging of Pacific predators, revealing their incredible journeys across vast ocean expanses. These 14 field projects, each a testament to scientific specialization, were complemented by the 3 non-field census projects we mentioned earlier, HMAP, FMAP, and OBS. To foster even wider participation, a network of national and regional implementation committees, or NRICs, was established, ensuring that countries and regions across the globe could actively engage in census activities. As the project neared its conclusion, additional teams were formed to focus on education and outreach, ensuring that the incredible discoveries reached a global audience, and on mapping and visualization, creating compelling ways to represent the vast amounts of data collected. A dedicated synthesis group meticulously coordinated the final outcomes, from scientific publications to public reports. The legacy of the Census of Marine Life is truly astounding. Over its decade-long lifespan, it engaged approximately 2,700 scientists from more than 80 countries. These dedicated researchers collectively spent an astonishing 9,000 days at sea, participating in over 540 officially recognized census expeditions, alongside countless nearshore sampling events. This monumental effort yielded thousands of records of previously known species, but more importantly, census scientists discovered over 6,000 marine species potentially new to science. By 2010, they had completed formal descriptions for 1,200 of these newly identified organisms. From a majestic blue whale to the most minute zooplankton and microbes, from the world's coldest regions to the warm, vibrant tropics, from the extreme environments of deep-sea hydrothermal vents to the delicate balance of coastal ecosystems, census scientists traverse the entire spectrum of marine habitats. They track the incredible movements of fish, piece together historical records, to understand the ocean before significant human impact and employed sophisticated forecasting methods to predict the future trajectory of marine life. By 2011, this extraordinary collaboration, widely acknowledged as one of the largest scientific endeavors ever conducted, had produced over 3,100 scientific papers and many thousands of other valuable information products. Critically, over 30 million species distribution records were made freely available through OBS, creating an invaluable open-access resource for researchers worldwide. Beyond the tangible scientific outputs, the census played an instrumental role in forging a global community of researchers. Many of these scientists, hailing from diverse backgrounds and institutions, had never collaborated before being brought together under the unifying banner of the census. It fostered a new paradigm for collaborative research, a testament to the power of shared purpose. As Ian Pointer, the outgoing chair of the census, eloquently put it, the census changed our views on how things could be done. We shared our problems, and we shared our solutions. The 2011 review commissioned by the Alfred P. Sloan Foundation highlighted the transformative impact of the census. Prior to its inception, the marine biodiversity research community was often fragmented, with few actively coordinated national and international programs. Taxonomic research, in particular, was often underfunded and scattered. There was, crucially, no ingrained culture of widespread collaboration and data sharing. Unlike the physical oceanography community, marine biology was characterized by smaller, often isolated projects, with little experience or willingness to openly share data. Furthermore, there was no recognized, open-access data portal for marine biodiversity information, a stark contrast to the established data depositories and common standards within the physical sciences. In their summarizing remarks, Pittman et al. Unequivocally stated in 2011, the census, by any statistical measure, was a great success. The large number of scientific papers published and still to be published by census participants alone would be sufficient. Instead, the census has achieved truly global science in biology. It did not profess to provide a complete census of life in the ocean in 2010, but it did substantially increase the baselines of knowledge in often underexplored ocean realms. From this knowledge base, future research and surveys will add more data that can be shared through web-based services such as OBS. From this, we may be able to derive estimates of population diversity, distribution, and abundance for selected groups of organisms or regions, and a future compilation of such data will show how far our knowledge has moved from 2010. Undoubtedly, much research on marine biodiversity would have been carried out over the last decade without the census, but it would have lacked the global reach and the access to data and technologies that made the census unique. In recognition of its decade of groundbreaking international ocean research, spanning multiple scientific disciplines, the Census Steering Committee was awarded the prestigious International Cosmos Prize in 2011. This esteemed accolade underscored the profound and lasting impact of their tireless efforts. The Census of Marine Life also forged impactful partnerships that extended its reach and amplified its discoveries. It collaborated with the Encyclopedia of Life, contributing extensively to the creation of pages for marine species, thus enriching a global repository of biological knowledge. It also supplied marine material for DNA barcoding within the ambitious Barcode of Life project, contributing to a global effort to identify and catalog life through its genetic signatures. Perhaps one of its most visible collaborations was with Google Earth 5.0. The Ocean in Google Earth feature incorporated a dedicated layer for the Census of Marine Life, allowing users to virtually join scientists on expeditions, exploring the incredible marine life and features discovered during the census. This partnership brought the wonders of the deep sea directly to millions, fostering a deeper connection and appreciation for our planet's oceans. Furthermore, a partnership with the French film company Galatea Films resulted in the production of the critically acclaimed film Oceans, released in 2009. This breathtaking documentary showcased over 200 species filmed in more than 50 global locations, bringing the majesty and mystery of marine life to the silver screen, captivating audiences worldwide. The Census of Marine Life, an undertaking of unprecedented scale and ambition, stands as a beacon of what can be achieved when scientific minds unite across borders with a common purpose. It didn't just count the uncountable. It revealed a universe beneath the waves, fostered a global community of explorers, and laid a robust foundation for future generations to continue unraveling the profound mysteries of our blue planet. Its legacy continues to reverberate, reminding us that there is always more to discover, more to understand, and more to protect in the vast, awe-inspiring realm of the ocean. Our journey into the ocean's depths is a timeless pursuit, an inherent human curiosity that beckons us to explore the unknown. But what if we were to embark on an organized, global quest to understand the very fabric of life beneath the waves? This was the audacious premise behind the Census of Marine Life, an endeavor so vast, so intricate, and so profoundly collaborative that it redefined our understanding of scientific exploration. Imagine a tapestry woven from the threads of countless expeditions, where over 2,700 researchers from more than 80 nations, united by a singular purpose, descended into the ocean's enigmatic realms. This wasn't merely a collection of isolated studies, but a symphony of scientific discovery orchestrated over a decade, with a final cost reaching an astounding $650 million. The culmination of this monumental effort, the first comprehensive census of marine life, was unveiled in London in 2010, a testament to what humanity can achieve when it sets its collective mind to unraveling the planet's deepest mysteries. The initial spark for this grand undertaking was fanned in the quiet conversations of 1996 between Jesse Ozabel, a senior research associate at Rockefeller University, and Dr. J. Frederick Grassel, a distinguished oceanographer and benthic ecology professor at Rutgers University. Dr. Grassel, a man of profound insight, had been encouraged to connect with Ozabel by former colleagues at the Woods Hole Oceanographic Institution. Unbeknownst to Grassel at the time, Ozabel was also a program manager at the Alfred P. Sloan Foundation, an organization renowned for its generous support of large-scale, public good scientific ventures, such as the Sloan Digital Sky Survey. It was Ozabel's foresight and persuasive influence that convinced the Sloan Foundation to invest in a series of feasibility workshops from 1997 to 1998. These workshops were crucial, broadening the initial, more modest concept of a census of the fishes into the far more ambitious and encompassing vision of a comprehensive census of marine life. The insights gleaned from these pivotal gatherings, alongside invited contributions, formed the bedrock of a special issue of Oceanography magazine in 1999. Later that same year, a workshop held in Washington, D.C. laid the groundwork for the Ocean Biogeographic Information System, or OBIS. This revolutionary system was designed to collate existing knowledge on the distribution of marine organisms, effectively becoming the central nervous system for the census's vast information management needs. The census officially commenced in May 2000, marked by the announcement of 8 grants totaling approximately $4 million, all dedicated to establishing OBIS. This significant step was duly reported in Science magazine that June. Concurrently, an international scientific steering committee, formed in 1999, began to chart the course for the coming years. By 2001, their vision included about half a dozen pilot field programs slated for 2002 to 2004. These initial forays, alongside OBIS and another groundbreaking project titled History of Marine Animal Populations, or HMAP, would constitute the census's foundational activities. This phase was to be followed by a series of additional field programs from 2005 to 2007, culminating in an intensive analysis and integration phase from 2008 to 2010. During the census's operation, an additional non-field project was incorporated, the Future of Marine Animal Populations, or FMAP. This initiative concentrated on forecasting the future of marine life using sophisticated modeling and simulation tools, offering a glimpse into the ocean's potential trajectory. The operational methodology of the census was carefully structured. Project proposals would undergo rigorous debate within the Scientific Steering Committee. If recommended for funding, a formal submission would be made to the Sloan Foundation. This funding supported the principal investigators, a project coordinator, crucial participant meetings, and essential synthesis, education, and outreach activities. The Sloan Foundation's approval was often contingent upon commitments from additional funding sources, and projects were actively encouraged to secure further resources during their operation. This strategic approach effectively leveraged the Foundation's initial $75 million contribution many times over, transforming it into a far more substantial program than would have otherwise been possible. Beyond direct project funding, the Foundation also supported core infrastructure components, including the Census's International Scientific Steering Committee and Secretariat, the U.S. National Committee, and an education and outreach network. These components were vital for elevating the project's visibility and engaging a wider array of nations and organizations. Ultimately, the census was estimated to have cost $650 million, with the Sloan Foundation contributing $75 million and the remainder supplied by a vast network of participating institutions, countries, and national and international organizations through both direct and in-kind contributions. In a retrospective review published in 2011, David Penman and his co-authors reflected on the genesis of this colossal undertaking. They highlighted the pivotal role of a visionary leader, Grassel, who was able to convince a small group of colleagues of the need for such a project and find a like-minded individual, Ozabel, who saw the opportunity for the Sloan Foundation to take a key role in bringing the census to fruition. This wasn't leadership driven by a search for problems to solve, but rather one that identified a critical issue that defied conventional national funding mechanisms. It was an issue that could only be addressed through a large-scale, collaborative endeavor. The Sloan Foundation, in turn, recognized a profound opportunity to facilitate new science that would simultaneously deliver immense societal benefit. This symbiotic relationship between visionary leadership, strategic funding, and collaborative spirit was the fertile ground from which the Census of Marine Life blossomed. The census was meticulously structured around three overarching thematic questions, each designed to illuminate a different facet of ocean life. What has lived in the oceans? What does live in the oceans? And what will live in the oceans? The most expansive component of a census involved a deep dive into what currently inhabits the world's oceans, spearheaded by 14 distinct field projects. Each of these projects meticulously sampled the biota within one of 6 vast realms of the global oceans, employing a diverse array of cutting-edge technologies. These investigations span the planet, from the icy reaches of the Arctic Ocean, under the banner of Arcady, or Arctic Ocean Diversity, to the equally frigid, yet vibrantly alive, Antarctic Ocean, explored by CML, the Census of Antarctic Marine Life. Mid-ocean ridges, those majestic undersea mountain ranges, were the focus of MARECO, the Mid-Atlantic Ridge Ecosystem Project, revealing the unique life forms thriving in these volcanic landscapes. The enigmatic world of vents and seeps, where life flourishes without sunlight, was charted by CHESS, dedicated to the biogeography of deep-water chemosynthetic ecosystems. The vast, often overlooked abyssal plains, the ocean's deepest floors, were explored by Pseudomar, the Census of Diversity of Abyssal Marine Life. Seamounts, those underwater mountains teeming with unique biodiversity, were globally cataloged by CENSEAM, the Global Census of Marine Life on Seamounts. The dynamic continental margins, where land meets deep sea, were studied by COMARCH, the Continental Margin Ecosystems Project. Moving closer to shore, the expansive continental shelves were tracked by POST, the Pacific Ocean Shelf Tracking Project, while the crucial nearshore environments were meticulously documented by NAGISA, or Natural Geography, in shore areas. The vibrant, yet vulnerable, coral reefs were the subject of CREEFs, the Census of Coral Reefs. Regional ecosystems, like the rich Gulf of Maine, received dedicated attention through the GOMA program. Beyond macroscopic life, the microscopic world was not forgotten, with ICOM, the International Census of Marine Microbes, delving into the unseen architects of ocean chemistry. The vast swarms of zooplankton, vital to the marine food web, with a focus of CMAR-Z, the Census of Marine Zooplankton. Finally, the ocean's apex predators were brought into focus by TOPP, the tagging of Pacific predators, providing unprecedented insights into their movements and behaviors. These 14 field projects were elegantly complemented by the 3 non-field census projects we touched upon earlier. HMAP, focusing on the history of marine animal populations. FMAP, peering into the future of marine life through modeling. And OBIS, the essential hub for all collected data. A series of national and regional implementation committees, or NRICs, were also established, crucial for fostering involvement from specific countries and regions in census activities. As the project neared its conclusion, additional teams were formed to handle education and outreach, and to develop compelling mapping and visualization products. A dedicated synthesis group then coordinated the final outcomes, including publications and other crucial deliverables. Over its remarkable lifespan, the Census of Marine Life involved approximately 2,700 scientists from more than 80 countries. These dedicated individuals collectively spent 9,000 days at sea, participating in over 540 census-badged expeditions, not to mention countless nearshore sampling events. The sheer scale of this endeavor is almost unfathomable. Beyond the multitude of records for previously known species, census scientists identified over 6,000 marine species potentially new to science, and by 2010, had formally described 1,200 of them. These scientists traversed nearly every corner of the global ocean, studying organisms ranging in size from the colossal blue whale to the most minute zooplankton and microbes, including bacteria and viruses. They sampled from the world's coldest regions to the warmest tropics, from the extreme environments of deep-sea hydrothermal vents to the more familiar coastal ecosystems. They tracked the intricate movements of fish and painstakingly sifted through historical records to reconstruct what the ocean was like before significant human influence. And, through sophisticated forecasting methods, they endeavored to predict the future trajectory of ocean life. By any measure, the Census of Marine Life stands as one of the largest scientific collaborations ever undertaken. By 2011, it had produced over 3,100 scientific papers and many thousands of other information products, with over 30 million species distribution records freely accessible through OBIS. Beyond its tangible scientific legacy, the census was instrumental in forging a vibrant global community of researchers. Many of these scientists had never collaborated before, brought together under the unifying umbrella of the census. It fostered a new paradigm for collaborative research, a shift eloquently summarized by Ian Pointer, the outgoing chair of the census, who noted, "The census changed our views on how things could be done. We shared our problems, and we shared our solutions." A 2011 review of the census, commissioned by the Alfred P. Sloan Foundation and authored by David Penman and his colleagues, highlighted the transformative impact of the initiative. Prior to the census, they observed the marine biodiversity research community was fragmented. Active coordinated national and international research programs were scarce, and taxonomic research, in particular, was underfunded and scattered across disparate organizations. There was no established culture of collaboration and data sharing. Marine biology was characterized by small research projects leading to publications, but with little experience or willingness to openly collaborate and share data. Furthermore, unlike the physical science oceanographic community, there was no recognized open access data portal or common standards for sharing marine biodiversity data. In their summarizing remarks, Penman et al. Unequivocally declared in 2011 that the census, by any statistical measure, was a great success. The large number of scientific papers published and still to be published by census participants alone would be sufficient. Instead, the census has achieved truly global science in biology. They acknowledge that it did not claim to provide a complete census of all life in the ocean by 2010, but it undeniably and substantially increased the baselines of knowledge in often underexplored ocean realms. From this newfound knowledge base, future research and surveys will continue to add more data, which can be shared through web-based services like OBS. This continuous accumulation of data will allow us to derive increasingly accurate estimates of population diversity, distribution, and abundance for selected groups of organisms or regions, providing a clear measure of how far our knowledge has advanced since 2010. Without a doubt, much research on marine biodiversity would have been carried out over that decade, even without the census. However, as Penman et al. Concluded, it would have lacked the global reach and the access to data and technologies that made the census unique. In recognition of its decade of unparalleled international ocean research spanning multiple scientific disciplines, the Census Steering Committee was awarded the prestigious International Cosmos Prize in 2011. The Census of Marine Life also strategically forged powerful partnerships to amplify its impact and reach. It collaborated with the Encyclopedia of Life, contributing extensively to the creation of pages for countless marine species, enriching this vital online resource. Furthermore, it supplied a wealth of marine material for DNA barcoding as part of the ambitious Barcode of Life project, helping to build a comprehensive genetic library of Earth's biodiversity. One of its most visually compelling partnerships was with Google. The Census of Marine Life and Google teamed up for Google Earth 5.0, integrating a dedicated layer within Google Earth's ocean feature. This allowed users to virtually accompany census scientists on their expeditions, witnessing marine life and features discovered during the extensive research. Imagine, from the comfort of your home, diving into the digital depths, exploring alongside those who charted the unknown. A particularly captivating collaboration was with the renowned French film company, Galatea Films. This partnership culminated in the production of the breathtaking film Oceans, released in 2009. The documentary showcased stunning footage of over 200 species from more than 50 global locations, bringing the wonders of the deep sea directly to audiences worldwide and inspiring a new generation of ocean enthusiasts. These strategic partnerships were not just about dissemination. They were about democratizing knowledge, engaging a global audience, and ensuring the legacy of the census extended far beyond scientific publications, embedding the awe and importance of marine life into the public consciousness. From the present, our gaze inevitably drifts backward, drawn by the echoes of time, to understand the journey of marine life, and indeed, our own. The Census of Marine Life, while focused on the living oceans of its era, understood the profound importance of historical context. Its very framework was built upon three fundamental questions, a testament to the scientific method's enduring quest for comprehensive understanding. What has lived in the oceans? What does live in the oceans? And critically, what will live in the oceans? This commitment to understanding the past led to the formation of the History of Marine Animal Populations, or HMAP, a pivotal component of the census. HMAP wasn't about venturing into the deep with submersibles. It was about venturing into archives, into old logbooks, into the collective memory of humanity's interaction with the sea. It sought to unravel how human activity had shaped marine ecosystems over centuries, creating a vital baseline against which current observations could be measured. Imagine the painstaking work involved, poring over centuries-old whaling records, fishing journals, and even anecdotal accounts from coastal communities. These weren't pristine scientific data sets. They were often fragments, scattered across dusty libraries and forgotten attics. But within these fragments lay invaluable clues to the past abundance, distribution, and diversity of marine life. A sudden drop in recorded catches of a particular fish species in a 17th century port ledger might signify an early localized overfishing event. Descriptions of vast schools of whales in a 19th century explorer's diary offered a stark contrast to their depleted numbers today. HMAP revealed that the natural state of the oceans, even centuries ago, was not entirely untouched. Indigenous populations and early seafaring cultures had their impacts, though often on a smaller scale. However, with the advent of industrialized fishing, whaling, and global trade, the pace of change accelerated dramatically. We began to see how specific human interventions, from the introduction of new fishing technologies to the alteration of coastal habitats, rippled through marine food webs, sometimes with devastating and unforeseen consequences. This historical perspective was more than just an academic exercise. It was a sobering reminder of the resilience and fragility of ocean ecosystems. It taught us that what we consider normal today, in terms of species abundance or ecosystem health, might actually be a shadow of what once was. The concept of shifting baselines became critically important. The idea that each generation perceives the environment into which it is born as the natural standard, without realizing how much it has already changed from previous generations. HMAP helped to push back against these shifting baselines, offering a glimpse into a richer, more diverse past. The insights gleaned from HMAP were profound. For example, it became clear that some species, once thought to be naturally rare, were in fact heavily exploited to the point of near extinction before modern conservation efforts even began. It allowed scientists to model the potential recovery trajectories for endangered populations, knowing what their historical peaks might have been. It also highlighted the importance of long-term ecological data, demonstrating that even fragmented historical records could yield powerful predictive insights. But understanding the past wasn't enough. The census also looked forward through the future of marine animal populations, or FMAP. If HMAP was about archaeology, FMAP was about prognostication. This non-field project leveraged the vast amounts of data being collected by the 14 field programs, combined with the historical context from HMAP, to develop sophisticated modeling and simulation tools. FMAP sought to answer the crucial question, what will marine life look like in the decades and centuries to come? This involved complex mathematical models that integrated variables such as climate change projections, ocean acidification rates, expected human population growth, and evolving fishing practices. It aimed to forecast how changes in ocean temperature, salinity, oxygen levels, and nutrient availability might affect species distribution, migration patterns, and overall ecosystem health. Imagine the challenge of such a task. The ocean is an incredibly complex, interconnected system. A change in plankton distribution in one region could affect whale migration patterns thousands of miles away. Rising ocean temperatures could force species to move to cooler waters, altering entire food webs in both their old and new habitats. FMAP's models tried to account for these intricate relationships, painting a picture of potential futures, some optimistic, some deeply concerning. These forecasts became invaluable tools for policymakers and conservationists. By identifying potential hotspots of biodiversity loss or areas vulnerable to significant ecological shifts, FMAP provided a scientific basis for proactive conservation strategies. It helped in the design of marine protected areas, in setting sustainable fishing quotas, and in understanding the broader implications of global climate policies on ocean health. The interplay between HMAP and FMAP was symbiotic. The past informed the future, and the potential future highlighted the urgency of understanding the past. Without knowing how ecosystems had responded to past pressures, it would be difficult to predict their reactions to future ones. Conversely, the grim predictions of FMAP underscored the need to learn from history and avoid repeating past mistakes. Both HMAP and FMAP represented a departure from traditional, single-discipline marine biology. They were inherently interdisciplinary, drawing on oceanography, ecology, history, economics, and even sociology. This holistic approach was one of the defining characteristics of the entire Census of Marine Life, emphasizing that the ocean story is not a collection of isolated events, but a continuous, interconnected narrative stretching across geological epochs and human timelines. The narratives woven by HMAP of long-lost abundance and resilience, and the projections from FMAP of potential shifts and challenges collectively form a powerful reminder. They tell us that the ocean is not static. It is a living, breathing entity, constantly in flux, shaped by both natural forces and the indelible imprint of human civilization. As we continue our journey through these waters, understanding these echoes of the past and whispers of the future becomes not just an academic pursuit, but an imperative for the survival and thriving of marine life, and by extension, our own. The story of what has lived and what will live in the oceans is a story intimately entwined with our own existence, a saga unfolding with every passing tide. From the depths of the Mariana Trench to the bustling life within a single coral polyp, we've journeyed through the astounding variety of marine ecosystems. We've touched upon the evolutionary marvels that allowed creatures to thrive in conditions previously unimaginable, and we've listened to the ancient echoes of colossal beasts that once ruled the waves. Yet for all our explorations, for all our ever-advancing technology and insatiable curiosity, a profound question lingered, largely unanswered. How much do we truly know about the ocean's living inhabitants? This very question, so fundamental yet so sprawling in its scope, sparked one of the most ambitious and collaborative scientific endeavors in human history, the Census of Marine Life. Imagine a decade-long odyssey, uniting over 2,700 researchers from more than 80 nations, all focused on a singular, monumental goal: to assess, to explain, to understand the diversity, the distribution, and the sheer abundance of life across the entirety of our planet's vast oceans. This wasn't merely another research project. It was a global call to action, an unprecedented convergence of minds and resources. Initiated with vital seed funding from the Alfred P. Sloan Foundation, an organization known for investing in large-scale, public goods scientific ventures, the census quickly grew into a behemoth. With an eventual cost exceeding $650 million, the project managed to leverage that initial investment many times over, drawing in support from countless institutions, governments, and organizations worldwide. The sheer scale and collaborative spirit earned it a descriptor rarely bestowed: one of the largest scientific collaborations ever conducted. The genesis of such a grand undertaking often lies in humble conversations. For the census, it began in 1996 with an exchange between Jesse Ozabel, a senior research associate at Rockefeller University and science advisor to the Sloan Foundation, and Dr. J. Frederick Grassel, an esteemed oceanographer and benthic ecology professor at Rutgers University. Grassel, unaware of Ozabel's connection to the Sloan Foundation, was simply pursuing a discussion urged by former colleagues at the Woods Hole Oceanographic Institution. From these initial dialogues, an idea began to take root, an idea that would blossom from a census of the fishes into the comprehensive census of marine life. The Sloan Foundation, recognizing the immense potential and the critical need for such knowledge, agreed to fund a series of feasibility workshops between 1997 and 1998. These workshops were crucial, allowing scientists to debate and refine the project's scope, to grapple with the logistical challenges, and to envision how such an ambitious census could realistically be conducted. The broadening of the initial concept from a focus solely on fish to an all-encompassing marine life census was a direct result of these intensive discussions. By 1999, the insights gleaned from these workshops and additional expert contributions coalesced into a special issue of Oceanography magazine, laying the intellectual groundwork for the project. Later that same year, a pivotal workshop in Washington, D.C. addressed a critical piece of the puzzle: the formation of the Ocean Biogeographic Information System, or OBIS. This would serve as the central nervous system of the census, collating existing knowledge about marine organism distribution and forming the project's essential information management component. Formally, the census began its operational phase in May 2000, with the announcement of 8 initial grants totaling approximately $4 million, all directed towards establishing OBIS. Concurrently, an international scientific steering committee was formed, which by 2001 had mapped out an ambitious timeline. The early years, from 2002 to 2004, would focus on a handful of pilot field programs, alongside OBIS and another groundbreaking initiative, the History of Marine Animal Populations, or HMAP. These would pave the way for a more extensive series of field programs between 2005 and 2007, culminating in an intensive analysis and integration phase from 2008 to 2010. During its progression, an additional non-field project, the Future of Marine Animal Populations, or FMAP, was integrated, focusing on predictive modeling and simulations to forecast the future of ocean life. The operational model for the census was both innovative and effective. Project proposals would be rigorously debated within the Scientific Steering Committee. If recommended for funding, a formal submission would be made to the Sloan Foundation, providing support for the principal investigators, a project coordinator, crucial participant meetings, and essential synthesis and outreach activities. A key strategic element was that Sloan Foundation approval often hinged on commitments from additional funding sources. Projects were actively encouraged to secure supplementary resources throughout their operation. This smart leveraging of initial funds created a much more substantial program than would have been possible otherwise. Beyond individual projects, the Foundation also provided core infrastructure support for the Census International Scientific Steering Committee and Secretariat, the U.S. National Committee, and a dedicated education and outreach network. These components were vital for elevating the project's global visibility, fostering engagement with other nations and organizations, and ensuring the widespread dissemination of its findings. Ultimately, the estimated $650 million cost of the census was a testament to this collaborative spirit, with the Sloan Foundation contributing $75 million, and the overwhelming remainder flowing from participating institutions, countries, and a myriad of national and international bodies, both through direct financial support and invaluable in-kind contributions. In a retrospective review published in 2011, David Penman and his co-authors eloquently summarized the genesis of this colossal endeavor. The census had its inception in a visionary leader, Grassel, who was able to convince a small group of colleagues of the need for such a project and find a like-minded individual, Ozabel, who saw the opportunity for the Sloan Foundation to take a key role in bringing the census to fruition. They noted that this wasn't about solving existing problems, but rather identifying an issue that could not be addressed through conventional national funding mechanisms and could only be approached through a large-scale collaborative endeavor. The Sloan Foundation, in turn, recognized an unparalleled opportunity to facilitate new science that would also contribute knowledge for wide societal benefit. It was a perfect storm of vision, need, and philanthropic foresight. The census was meticulously structured around 3 overarching thematic questions, each probing a different facet of marine life's saga. What has lived in the oceans? What does live in the oceans? And what will live in the oceans? These questions form the backbone of the entire initiative, guiding research and fostering a holistic understanding of marine biodiversity across time. The largest and arguably most visible component of the census focused on the present, investigating what currently lives in the world's oceans. This was tackled through 14 distinct field projects, each meticulously designed to sample the biota within one of 6 broad realms of the global oceans, utilizing an impressive array of cutting-edge technologies. Imagine the breadth of this undertaking. We had ARC-OD, the Arctic Ocean Diversity Project, venturing into the frigid, often icebound waters of the Arctic to uncover life adapted to extreme cold and seasonal light. On the opposite pole, CML, the Census of Antarctic Marine Life, explored the equally harsh yet incredibly rich ecosystems surrounding the Antarctic continent. Then there was MARECO, the Mid-Atlantic Ridge Ecosystem Project, delving into the mysteries of the vast underwater mountain range that bisects the Atlantic, a realm of deep-sea corals and bizarre creatures. CHESS, focusing on the biogeography of deep-water chemosynthetic ecosystems, brought us to the otherworldly hydrothermal vents and cold seeps, where life flourishes without sunlight, drawing energy from chemical reactions. Pseudomar, the census of diversity of abyssal marine life, descended into the crushing pressures and perpetual darkness of the abyssal plains, exploring the vast, often overlooked seafloor. Censim, the global census of marine life on seamounts, investigated the unique ecosystems found on underwater mountains, biodiversity hotspots rising from the ocean floor. Comarch, continental margin ecosystems, explored the dynamic regions where continents meet the deep ocean, areas of intense biological activity and often significant human impact. POST, the Pacific Ocean Shelf Tracking Project, utilized sophisticated tagging technologies to track the movements of marine life across the continental shelves of the Pacific. NAGISA, the Natural Geography in Shore Areas Project, meticulously documented life in the vital, yet often threatened, nearshore environments. CREEFS, the Census of Coral Reefs, cataloged the astounding biodiversity of these critical rainforests of the sea. Regional programs like GOMA, the Gulf of Maine program, provided in-depth studies of specific, biologically significant regional ecosystems. ICOMM, the International Census of Marine Microbes, embarked on the microscopic frontier, revealing the incredible diversity and ecological importance of bacteria and viruses in the oceans. CMARZ, the Census of Marine Zooplankton, studied the drifting animal life that forms the base of so many marine food webs. And finally, TOPP, the tagging of Pacific predators, used advanced satellite tagging to track the epic journeys of apex predators across the vast expanse of the Pacific Ocean. These 14 immersive field projects were beautifully complemented by the 3 non-field census initiatives we mentioned earlier. HMAP, which delve into historical records to understand past marine populations. FMAP, which employed modeling and simulation to predict future trends. And OBIS, the indispensable data management system. To ensure truly global participation and impact, a network of national and regional implementation committees, or NRICs, was established, actively engaging specific countries and regions in the census's diverse activities. As the project drew towards its conclusion, additional specialized teams were formed for education and outreach, and for mapping and visualization products, culminating in a dedicated synthesis group that coordinated the final publications and outcomes. The sheer scale of the Census of Marine Life is almost unfathomable. Over its 10-year lifespan, it engaged approximately 2,700 scientists from more than 80 countries. These dedicated researchers collectively spent an astonishing 9,000 days at sea, participating in over 540 officially recognized census expeditions, not to mention countless nearshore sampling events. The expeditions were truly global, taking scientists from the world's coldest regions to the warm tropics, from the crushing pressures of deep-sea hydrothermal vents to the vibrant life of coastal ecosystems. They tracked the intricate movements of fish, meticulously interrogated historical records to understand the oceans before significant human influence, and employed sophisticated forecasting methods to predict the future trajectory of marine life. The scientific yield of this immense undertaking was nothing short of revolutionary. Beyond the thousands of records of previously known species, census scientists discovered over 6,000 marine species potentially new to science, with formal descriptions completed for 1,200 of them by the project's conclusion in 2010. This was not just about adding names to a list. It was about revealing entirely new branches on the tree of life, opening our eyes to the astonishing, hidden biodiversity of our planet. By 2011, A mere year after its official completion, the census had generated an astounding legacy. Over 3,100 scientific papers, countless other information products, and a staggering 30 million species distribution records, all made freely available through the Ocean Biogeographic Information System, OBIS. This unprecedented open access to data has transformed marine biology, providing a baseline of knowledge that will inform research and conservation for generations to come. Yet, the legacy of the census extends far beyond its tangible scientific output. It was instrumental in forging a truly global community of researchers, many of whom had never collaborated on such a scale before. As Ian Pointer, the outgoing chair of the census, eloquently put it, the census changed our views on how things could be done. We shared our problems, and we shared our solutions. This cultivated a new paradigm for collaborative research, breaking down disciplinary and national silos. Before the census, as noted by Penman et al. In their 2011 review commissioned by the Alfred P. Sloan Foundation, the marine biodiversity research community was often fragmented, with few active coordinated national and international research programs, and taxonomic research, in particular, was underfunded and scattered in disparate organizations. Critically, there was no culture of collaboration and data sharing. Unlike the physical oceanographic community, marine biology was characterized by smaller, isolated research projects with little willingness to openly share data. Furthermore, there was no recognized open-access data portal for marine biodiversity data. The census, by design, fundamentally addressed and dismantled these barriers. In their summarizing remarks, Penman and his co-authors concluded that the census, by any statistical measure, was a great success. The large number of scientific papers published and still to be published by census participants alone would be sufficient, but they went further, emphasizing that the census had achieved truly global science and biology. While it never claimed to provide a complete inventory of ocean life in 2010, it undeniably substantially increased the baselines of knowledge in often underexplored ocean realms. From this bedrock of newfound knowledge, future research and surveys will build, adding more data that can be shared through web-based services like OBS, allowing us to continuously refine our estimates of population diversity, distribution, and abundance. As Penman et al. Presciently stated, undoubtedly much research on marine biodiversity would have been carried out over the last decade without the census, but it would have lacked the global reach and the access to data and technologies that made the census unique. This sentiment encapsulates the transformative power of the Census of Marine Life. It didn't just add to our knowledge. It fundamentally changed how we acquire, share, and understand that knowledge. In recognition of its profound impact and its decade of unparalleled international ocean research spanning multiple scientific disciplines, the Census Steering Committee was awarded the prestigious International Cosmos Prize in 2011. The collaborative spirit of the census extended beyond the scientific community, forging key partnerships that amplified its reach and impact. It partnered with the Encyclopedia of Life, contributing extensively to the creation of pages for countless marine species, effectively bringing the ocean's inhabitants to a broader public audience. It also supplied invaluable marine material for DNA barcoding in the ambitious Barcode of Life project, contributing to a global genetic library of all species. Perhaps one of its most innovative partnerships was with Google. The 2009 release of Google Earth 5.0, with its groundbreaking ocean layer, included a dedicated section for the Census of Marine Life. This allowed users worldwide to virtually follow scientists on their expeditions, to witness the breathtaking marine life discovered, and to explore the features mapped during the census, making the wonders of the deep accessible from anywhere. Furthermore, a partnership with the French film company Galatea Films culminated in the production of the critically acclaimed film Oceans, released in 2009. Featuring stunning footage of over 200 species filmed in more than 50 global locations, the film brought the beauty and fragility of marine life into cinemas, captivating audiences and furthering the census's mission of awareness and appreciation. The Census of Marine Life stands as a monumental testament to what can be achieved when humanity unites behind a shared scientific vision. It didn't just count the uncountable. It inspired a new era of oceanic exploration, collaboration, and understanding. It left us with a far richer tapestry of knowledge about the life that shares our blue planet, a legacy that continues to shape marine science and conservation efforts to this very day. As we gaze upon the vast, shimmering surface of the ocean, we now do so with a deeper appreciation for the intricate, vibrant, and still mysterious world that thrives beneath. As we gently resurface from this extraordinary dive into the census of marine life, it's clear that the ocean's story is far from fully told. Each discovery, each collaboration, reminds us of the endless wonders that persist beneath the waves and the incredible human spirit of inquiry. I hope this deep dive offered you a moment of quiet contemplation and profound insight. If you enjoyed this journey, please consider liking, sharing, and subscribing to Vibing Science for more explorations into the universe's grand narrative. What are your thoughts on this colossal scientific undertaking? And what other cosmic or earthly mysteries would you like us to unravel next? Until then, keep looking deeper and keep wondering.